Hey everyone, I am TH Pine and welcome to TIS-100. What is TIS-100 you ask? I like to call it Assembly Programming, the video game. It's by Tektronix, the guy who made Ironclad Tactics, Infinifactory and Space Jam, and it's available on Steam Early Access, and this is what it looks like. So this game's about assembly programming, so one important question obviously is this game accessible to people who have no experience in programming whatsoever? And my answer to that is yes and no. So the assembly programming you have to learn is fairly simple, and the tools you're given are very good, and Tektronix is really good at getting that learning curve right, so I think it is potentially accessible, but you have to want it. You have to want to learn it. Like, there is learning involved, and you have to want it. You need to bring the patience and the passion, and I think most people who will bring that patience and passion will have looked into programming at some point earlier in their life already. Not everyone, so there might be a small amount of people who have the patience to to go through this, through the learning process, and did not touch programming yet, but I think those amount of players is very small. But if you're interested, feel free to go for it. So let me go a little bit more into detail about that. So there's a manual. You're supposed to read that manual. It's not very long, and you don't have to read the full manual to start the first few levels, because it will touch later subjects that are not necessary for the first few levels as well. And the manual is pretty well written. It's, as I said, it's fairly short, and it's written in character, quote unquote. So the game has a story, believe it or not, and the manual includes notes and stuff, and stuff is marked, some lines are marked, and stuff like that. So it's fairly interesting to read, and it's not too long, and it's very well explained as well, in my opinion. As I said earlier, Tektronix gets this learning curve very right, as always, because they're pretty good at this. They weren't really good at it like a few years ago, but today they're really good at that. So let's just talk about the first level, for example. So the first level is this. So this is how the game looks. So you have those nodes. Those nodes can communicate with each other with those arrows. So adjacent nodes can write numbers to each other. So everything works on decimal numbers. There's no binary involved or anything. Nothing crazy like that. No ones and zeros. Well, you can write ones and zeros, but you can write any number. So there's that. There are some nodes that are broken, communication failure, because you're about to repair this TIS-100, which is this microcomputer thingy. And if you press those debug buttons, then you see what I mean about story. So your uncle who owns this thing left notes behind in that microcomputer, and you can read those. And there's some story involved, as I said. So those are broken, so we cannot use those, but we can use the other ones. And in this level, we're supposed to read a value from in A is up here, and write a value to out A, which is down here. So what we have to do is we have to read the value from here and move it over like this way with those nodes, or with those nodes down there. So let's do that. How do we do that? There are a bunch of commands. You can press F1 to get a look, or instruction set, and god damn it, sorry. You can press F1 to get a quick reference about all the commands or instructions. There are not too many, as you can see. Most of them are, or half of them are jumps, which we'll get to later. And the most important one is the move command. Move source to destination. So we're gonna do that. We do move up to left. So what this is going to do is it reads the value from in A, and it will write it to the node to the left, so this node. So what we're going to do here is we move the node from the right down, and move up down, move up right. There are hotkeys. Control arrow keys lets you jump between nodes. That's quite useful. Move, so you don't have to touch the mouse actually. Move left right, and move left down. By the way, here everything is working here. You can do control copy and stuff like that, like this, and like yeah. It's a pretty good editor, actually. It looks very basic and console-like, but it actually supports most of the Windows hotkeys and stuff, so that's quite useful. Okay, so let's run this. What you're gonna see is that the nodes will work, and they will transport those numbers, the input you can see on the left, down to the output, and then we get a score. We're getting three scores actually. You get a cycle count, a node count, and instruction count. So cycle count is how long it took, node count is how many nodes did we use, instruction count how many instructions did we write down. So we can do it step by step to show it a little bit more slowly. So the first thing that happens for a cycle is move up left, we read in that value and write it to the left. This node will pick it up, write it down there, dab, 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 the 14 is going over here, and finally going to the output, and it shows up here, and you see with the other numbers, that works as well. Bop, and we can speed it up, and there we go. So that's the first level, fairly basic, but a good introduction. So let's go to the second level, a little bit more interesting. Second level, you have to read a value from in A, double the value, and write the value to out A. So what we're gonna do is, we move up to ACK. ACK is like your variable. It's a thing you can save a number in, basically. So what we're gonna do, if it like just press a step button, for example. So what it does, it moves the 11, which comes from the input, and puts it in the ACK thing over here. So you can save a number in there, and you can now do something with the number. For example, we could move ACK down. So what's gonna happen now is, oh, I did not explain that earlier, by the way. If you are writing multiple lines of code, or if you're writing one line of code as well, if the code ends the last, or reaches the last line, it will jump to the first line again, which is why the first level actually worked and did not only move one number, but moved multiple numbers. So each node will go through through all the lines in a sequential order. So it will first move up to ACK. 11 is in ACK now, and then it will move ACK to down. So it will use the 11 and put it in down. Move is a copy here, by the way. It's not actually moving it from ACK. So ACK will stay 11, and we will move 11 down here. This node will not read it, so this is locked down now, and nothing's gonna happen because he's trying to write it down, but the node at his the down node is not reading it. So that's not gonna work well. But we can now move up to ACK. And now we have to figure out, how do we fucking add this? So there are multiple ways of doing this. The easiest one is probably, yeah, let's do it this way. So there's an add command. Add source to ACK. So whatever we put in source, we'll add it to the ACK. So we moved the number to ACK. So what we can do is now we add ACK. And then we move ACK down. And what's going to happen now is we write the 11 to the ACK, then we add 11 to the ACK, or we add ACK to ACK, which makes 22 in ACK, and then we move to 22. We could have done that in the first node as well, obviously. Move up right, move left down, and run, and it works. Sweet. So that's the second level. We're not done with the second level yet, though, because this game is about optimizing. Well, let's first try another way of doing it. For example, what we could do is we could do move ACK down here, and now we will write the number twice. What we can do now is we don't add ACK, we add up. That's not necessarily better, but it's a different way of doing it. It's probably worse, actually, from runtime. But so what's going to happen now is we write D11 to ACK, then we write D11 down here. It will be written to this ACK, and then we write the 11 down here as well again, and it will be added again to the ACK. And that's an easy way to sum, or to double values, or add values in general. And then the result will be given to this node and moved to the exit, and it's pretty slow. So not a good way of doing it. Anyway, there's a pretty good way of doing it I want to show you, because as I said, this game is about optimizing. So how can we make this quicker? Well, we can make this quicker by parallelizing. So we use multiple nodes to actually double our values. So we have, in this node, we have move up any. Up, we're getting the input, and we move it to any. Any means whichever nodes makes a read input, or read command, will get the value. So this node will never read because it has no instructions at all. So one of those two nodes will read the value which is coming from here. Whoever is quicker, and if they're if they have the same, like if they're reading at the same time, then I think this one has priority, but I'm not quite sure. I think it goes like this from the priority wise. So this node will read the value from the input node and double it, and then move it down. And this value will do the same and move it down to the right, though, so to the same node over here. And this node will read from any, so from here or here, whoever writes first, and then move it down. So we parallelized it. Let's take a look closer. So we get an 11, move the 11 to whoever wants to read it. He gets it, the right node. puts it in his egg, doubles it up, has a 22, and will now move it down here. Meanwhile, though, at the same time, we got a 12 from the input, and we're reading or writing the 12 to this node. And so we're getting the 22 over here, but in the meantime, the 12 is actually going to double up here in this node already. So those nodes are actually working at the same time parallel to each other, which will speed up the process. Now the 24 is getting over here, and they're staying in order because the nodes are quick, have the same speed, so they never, like, it's never two numbers from this node and then 2 from this or something. It's always alternating. We could make sure it's always alternating by having by not using the any command and instead using move up right, move up down, and move up down, move left down. That would ensure that it's alternated, but since they're quick enough, they're the same speed, they will automatically alternate. And since we want to optimize, and one of the scores is low number of instructions, this is obviously more optimized, quote unquote, because we have 2 less instructions because we use the any. So let's run it, and you can see it's fairly quick. We got 84 cycles, which is the optimum for this level. Very nice. You can always see your friend statistics here, so compared to your friends, and you see those global histograms. They're not pretty good though. They have the same problem as an Infinifactory, and I really hope they fix that. I want to see the global leaderboard. I want to see, like, the perfect way of displaying this, in my opinion, would be leaderboards, 3 leaderboards. Well, actually, the perfect way would be 1 leaderboard with 3 columns: cycle count, node count, and instruction count, and you can order it by whatever column, and you can have a secondary order as well. So I can say I want to have it primarily ordered by cycle count and secondary ordered by node count. Or I have it primarily ordered by cycle count and secondary by instruction count, or primarily by node count, and whatever. You get the idea. I really want that because it's so hard to figure out if you're not going to the Reddit and comparing to other people's scores there. If you have the best score in a specific category, words. So that's a little unfortunate. I hope they fix that. The game is still in early access. The game is, by the way, let's talk about early access really quick before we go to a more complex level. So the game's in early access, yes, but it's basically finished already. Really, Tektronic said it as well. They did it like an Infinifactory. They completed the game, but they have still a few things they want to add, or they want some feedback and see what the players want. For example, better score system, maybe. Not better score system, but better statistics, maybe. That would be an improvement, in my opinion. And they want to polish up the game a little more and then finally release it. But the game is very much complete already. The story is completely there. If they go in the same path as with Infinifactory, they will put in a few more puzzles and levels as well. We're gonna might see even more content. That's the hope anyway. But the game is very much complete already, in my opinion. So this is a finished game, basically. So let's go to the signal multiplexer. I just wanted to solve this? No, I just want to show you my solution. I think this one probably. Yeah, this one, right. Okay, because I want to show you this one because it's about jumps. So jumps are a very important thing in assembly programming. Jumps do not really exist in regular programming because you use logic there, like if and loops and stuff like that, so conditions and loops. But you don't really have that on assembly level, so you have to use jumps. So what is a jump? We have jump commands, 6 jump commands, 7 jump commands, no, 6. So we have a regular jump. If the code will reach the jump command, it will always jump to the label. A label, you can define a label by writing something and put in what's the word? A colon? Colon is the word, right, in English? I think. Behind it. So E colon is a label, for example. Or we could do whatever, like blah blub. That's a label now. It's called blah blub. It's not actually a line, like it's a line of code, but it's not an instruction. So when the code reaches the E, it will not do anything. You can even put the label in front of another instruction. So as you can see here, we have a label called L, and then it's that short because I had to write more code behind it because the editor is actually limited. We cannot put more than one, like we only have 1 line left. So I had to save space. So it will ignore the label when the code reaches it, and then do the instruction process the instruction. So what are labels for? You can jump to labels. So for example, if you would write jump L, and the code reaches this label, which it will do because it's the first instruction, except for the label up here, but as I said, it ignores labels normally, then it will jump to this label and will proceed with this instruction. So it will do the move right act. That's not useful though, so let's not do that. But instead, let's talk about other jumps, because that doesn't sound too useful, doesn't it? We could just write it right there, what we want to do. So what are jumps for? Jumps can be conditioned. So there are 5 conditioned jumps. They normally, and I have a son in my background. Just ignore him; he's fine. So there are 5 conditioned jumps, and they normally compare something from what is written in egg to 0. So we have JEZ, which will compare the egg to equals 0. That's easy, equals 0. So if egg is easy, is equals 0. If egg is 0, then the jump will be preceded, and we will jump. If egg is not 0, it will not jump. Then we have not 0, greater than 0, and lower than or lesser than 0. And then we have JRO, which is really weird jump. I did not use yet. You can basically say jump 3 lines with that, or jump 2 lines, or whatever, which is a little strange. I think there will be uses later in the game for this, but I did not use it yet. So anyway, so for this level, we have to read A and B, and we have to read S. So we have in A, in B, and in S, and determined by S, we have to do something with A and B. So if S is -1, we have to write A to the output. If S is 1, we have to write B to the output. And if S is 0, we have to write A plus B to the output. So how do we do that? We write A and B with those nodes and write it to this node. And this node reads S and puts it in egg, and then does jumps. So is egg greater than 0? If so, jump to G. If it's lower than 0, okay, so if it is not greater than 0, then it will proceed here and will check for this jump. Is it lower than 0, then jump to L. So if it's not greater or lower than 0, then it obviously is equals to 0. So we have to add A and B. So what we're going to do is we move left to egg, which is A, and then we add right, which is B. So now we have A plus B on egg, and now we jump to E. And E is move egg down. So move whatever is in egg and move it down and put it to the output. And if you now take a look at G, egg is greater than 0, so we have 1 in S. Then we only want B, so we have to read A, so we don't get this. So this node is not getting stuck. So we have to read A. We write it in egg. But we could do something else here to make it a little bit more clear. Write to nil. Nil is basically nothing. If you write to nil, nothing will happen. We just read the value. So this node is not getting stuck. We read from right, put it in egg, and jump to E. So we move it down. And for L, we do the other thing around. We move right to nil, and move left to egg, and put it down. And as you can see here, so the first value on S is a 1, so we have to write B. So what's going to happen? The jump greater than 0 will be executed. Bam, there we go. It jumps to G. Move left nil, so we erase this -26. Boop, it's gone. Move right egg, so we read that 21 to egg, and then jump to E. Move egg down, so we write 21 to this node down here. Bam, there we go. 21 will go to the output, and we're starting from the first line again. Not sure why I have a start label here. Actually, I don't need that. I think that's probably. I thought I would need it, but I did not need it. So we could remove that, and. There we go, and that was -1 now, so we're jumping to L, move right to nil, move left to egg, move egg down, and for the 0, there's a 0, move ab egg, so egg 0 now, nope, move left to egg, add right, there we go, egg is -8, -20 plus 12, and we write -8 down here. Sweet, so that works, and we get a pretty decent score. You can optimize this though. Let's get rid of that label. And actually, I think we might wait. How many cycles was that? 291. I have a different solution, but 291 for this solution. I think we can improve that by 1 cycle if we if we change some orders around. I'm not quite sure yet. This might work or might not. Actually, we can. We have enough space now. We can do it this way. Let's see if this is quicker. No, it's not. Okay, never mind. I thought it would be, but apparently not. Doesn't matter. Anyway, so this is the way to solve this level, and it explains jumps very well. That's why I showed this level. You can optimize this though. For example, this is still not the perfect solution, but this is the solution I came up with. I basically parallelized it again. Instead of collecting the numbers in this middle node, I write the instruction number from S, or not the instruction, well, the input, the S input to left and right, and let the A and B node decide what to do with their values, and then add them up here, whatever comes, and they just write 0 if they think if the value is not needed. So that's, for example, a way to improve that level. So let me show you one more thing. Well, two more things. There is a sandbox. No, let's talk about something else first. We talk about this level first. So there are more node types. That's what I was looking for. For example, a stack memory node, which basically is a stack. So you cannot write code in there. It has code in there already, basically, and you can use it as a stack. So you can put numbers in there, and they will stack on each other, and you can read numbers from the top of the stack. And you can use that, for example, for this level where you have to read a sequence of numbers. The sequence is terminated by a 0, and then you have to reverse the sequence and write to the output. So what you do basically is you write all the numbers until you reach a 0 to the stack, or to this stack, whatever, and then you read the numbers from that stack in the reversed order, because you're reading the stack from top to bottom, but you're filling it from bottom to top, and then you write it to the output. It's not that simple as it sounds though, because you have to count how many numbers did I put in the stack, and then you have to figure out how many read operations you have to do. So it's not that trivial, but maybe there's a way around. I did not solve it yet, but I have an idea how to do it. Anyway, so that's stack nodes. Later there will be graphical nodes as well, where you can do, like, you can print pixels and do pictures and stuff. I did not unlock those yet though, so I cannot show them to you. I want to show you one more thing. The memory, the sandbox. I mean, there's a simple sandbox. Here's a stack sandbox. Let's take a look at that. So that's a sandbox. So you just get empty nodes, and you have a console, and you can write inputs in the console, and it will use that. Like, for example, we can do move up, down, move up, right, move left, down, move up, down, and now we can run it, and we can type something in the console, for example, a 1, and the 1 goes through and comes back to the console. It's like a console. So we can write text? No. That would be funny. No, we can write numbers though, 1 and 23, and the console gives it back. We could do anything with, so you can basically use those. Well, it's a sandbox. You can write your own programs and do whatever you want, and that might be interesting for the graphical sandbox later, but I don't have that unlocked yet, as I said. So anyway, that brings us to the end of this video, I think. Is there something else I want to talk about? No, I touched anything. So as I said, early access, yes, but it's basically completed already. I think if you watch the video until now, you have a good idea if you want to check out this game or not. I really like it, but I'm a huge nerd, so that's that. Anyway, I love that, like Tektronic, I love them. They create really, really good puzzle games, and there are not a lot of developers who create really, really good puzzle games. And yeah, I like good puzzle games, and they're rare, and this is one of them. It's really, really fucking hardcore though. It's not. There's one more game which is even more hardcore from Tektronics. One of the earlier games. It's called, I think, Constructor Engineer of the People. I think that's the name. That's as hardcore as it gets. That was not really even a game, actually. Well, it was a game, but wow, that was fucking hardcore. It's about silicon and creating logic with silicon and iron. It was pretty crazy. Anyway, so yeah, if you want to check that out, it's free on Congregate, I think. Yeah, pretty great game. I spent a lot of hours on that, but it has a terrible tutorial. That's what I meant earlier when I said that we're not that good with the. Did I say that in this recording? In this take of the recording, I might have said that in an earlier take of the recording. Tektronics is really good at getting this learning curve right and getting good tutorials these days, but they weren't back then. The tutorial for Engineer of the People was terrible. But it made the game even more hardcore, so that's fine. Anyway, so this is TIS-100. It's available in Steam Early Access. Link is in the description below. It will probably release fairly soon because, as I said, the game is pretty polished already. So yeah, if you feel free to, if you feel like digging into some assembly programming, feel free to check it out. I highly recommend it. I'm TH Pine. Thanks a lot for watching. Have fun and see you next time.